This is the video for 6-1, and we are talking about systems of linear equations. A system of linear equations is two or more linear equations. So for example, if I have y equals 3x plus 7 and y equals 4x minus 2, I have a system of linear equations. A solution of a system of linear equations is any ordered pair that makes all of the equations in a system true. So in other words, it is the xy coordinate that will make both of these equations true. It is their point of intersection. So when a problem asks you to solve a system of linear equations, what it is asking you to do is find the point of intersection, or find the xy coordinate that will make both of these equations true. So a system can be consistent or it can be inconsistent. A consistent system is a system of equations that has at least one point of intersection. So a consistent system is a system of equations that has at least one solution. There is at least one point of intersection. A consistent system can either be dependent or independent. An independent system is a consistent system that has exactly one solution. So there is one point of intersection. A dependent system is a consistent system that has infinitely many solutions. In other words, they are the same line. An inconsistent system is a system of equations that has no solution. They will never intersect because they are parallel. So let me just review that for you one more time. A system of equations is two or more systems. So a system of linear equations is two or more linear equations that are on the same coordinate grid. They're graphed together on the same plane, and there's more than one, so you have a system of linear equations. A system of linear equations, which is more than one, can either be consistent or inconsistent. If it's consistent, it has at least one solution. There's at least one coordinate point that will make both of the equations true. There's at least one point of intersection. An inconsistent system has no point of intersection. There's no xy coordinate that will make both equations true. They will never intersect. In other words, they're parallel. So parallel lines will be inconsistent. Parallel lines are inconsistent, there's no solution. But if a system has at least one point of intersection, it's going to be consistent. Now, a consistent system with at least one point of intersection can either be dependent or independent. If it's independent, there's only one point of intersection. There's only one xy coordinate that will make both equations true. They intersect at one place. But a dependent consistent system has an infinite number of solutions. Why? They're the same line. So you can either have a consistent or an inconsistent system, and then a consistent system can either be dependent or independent. So now that we've gone over our vocabulary terms, let's just practice solving a system by graphing. There's 3 different ways to solve a system of equations, and the first way is by graphing. And so how do I solve a system by graphing? I just literally graph both equations and I find their point of intersection. So you should already know how to graph a straight line, and so you just graph both of the equations and you find their point of intersection. Here, their point of intersection is at 2, 4, and how do I check to make sure this is correct? I just plug this coordinate point back into both equations to make sure that it works for both equations. Make sure that this coordinate point will make both equations true. So we say that this system is consistent and independent. It has at least one point of intersection, and it has only one point of intersection at 2, 4. Okay, so pause the video and work out the on your own problems. Graph both of those equations on the coordinate plane and find their point of intersection. And once you do so, you find that they intersect at -2, 0. And so again, this is a consistent and independent system. And if I was to plug this coordinate point back into both of these equations, it would make both equations true. Example number 2, systems with infinitely many solutions or no solution. So I can graph these to determine if they are the same line or if they are parallel, but sometimes it's easier just to look at it. So if I take, and I'm also more accurate because on a graph, sometimes what looks like parallel lines aren't, and it can be very deceiving. So when you're talking about determining whether something it has an infinite number of solutions or no solutions, it's always better just to look at the equations and compare them. So what am I going to do? I want to put them both into the same form just so I can compare them. So I think this is I think the easiest thing to do here is to take this top equation and to put it into y equals mx plus b form. So how did I do that? I added x to both sides and then I divided everything by 2. And once I did so, what happened? If I compare that to the second line, I notice they're the same line. So what does that mean? There's an infinite number of solutions. There's an infinite number of x, y coordinate points that will make both of these equations true. So we say that this is a consistent and dependent system. It's consistent because there's at least one solution, and it's dependent because there is an infinite number of solutions for these 2 equations. These 2 equations here are consistent and dependent with an infinite number of solutions because they are the same line. And when I put them both into y equals mx plus b form and compare them, I can see they are the same line. So now look at this one. I can just look at these and I can compare them, and what do I notice? They have the same slope and different y-intercepts. Whenever you have 2 lines that have the same slope and different y-intercepts, they are parallel lines. There's no solution, they will never intersect, and there's no xy coordinate that will make both of these equations true. So we say that this is an inconsistent system. Again, same slope, different y-intercept, parallel lines. Please make sure you write that down. You need to remember that. Same slope, different y-intercepts, parallel lines, no solution. They will never intersect. Okay, so go ahead and hit pause and work out this last on your own problem. Okay, so the first one, there's no solution, they're parallel lines, It is an inconsistent system. And again, how do I know that? Same slope, different y-intercept. But look at this last one. They're the same line. There's an infinite number of solutions, so we say they're consistent and dependent. How do I know they're the same line? Well, this is already in slope-intercept form, so I want to take this and I want to put this into slope-intercept form as well so I can compare the two. So I'm going to divide everything by 3, and once I do so, what happens? I notice they're the same line. Okay, so you can go ahead and do the 6-1 homework now, but remember, I'm combining both lessons today, so you do have another video to watch on 6-2.